Hey, welcome back to Mr. PL's with Algebra. This is Unit 4, Topic 2, Lesson number 11, the last lesson of this topic. And we're going to put together everything we have learned so far up to this point with factored form, vertex form, and standard form, converting one to the other. And in this warm-up, we're going to talk about how each one is used for different things. So if we're given these three forms, which these are all equivalent, this is the factored form, vertex form, and standard form of this equation right here. Which expression would be most helpful for finding the amount of seconds it takes for the ball to hit the water? Now, if you think about a graph, when the ball hits the water, it has a height of 0. So what you're really looking for are what are the two intercepts. So if the equation looks kind of like this, I'm just making that up. So it would be hitting the water right here and right here. And the equation that makes it the easiest to find those two intercepts would be factored form, because the answers would be 6 and -2. As you can see, the factored form is really easy. So factored form is what I would choose for this one. Which expression is the most useful for finding the maximum height? Now, when you look at this parabola, the maximum height is the vertex. So the one way of writing an equation that would be the easiest to find the vertex would be vertex form. That's what I would use for number 2. If you want to know the height of the cliff above the lake, which expression would you use? Now, we have to assume that right here on the y-intercept, that is the cliff, that you're hitting golf ball off of here. And if you were to follow or trace the parabola of the golf ball as it's flying through the air, it would go backwards. And I know this side of the parabola doesn't really make sense because that would be backwards in time. But the idea is the y-intercept would be the height above the cliff, so therefore standard form would be the best, because standard form gives you the c term. Whatever the constant is always the y-intercept. All right. So as I said, this lesson is about changing one form to another. First question, we're given standard form. We want to change it to factored form. We're going to do that by factoring it. C is -12, so we're going to list all the factors of 12. We've got 1 times 12, 2 times 6, and 3 times 4. And we're looking for which one of those sets of factors is also going to add up to the b term, which is -1. Keep in mind that it's a -12, so one of the factors has to be a negative. And it looks like it's got to be the 4 and the 3, and the -1 has to be the 4. So that's going to be x minus 4 times x plus 3. All right, so there's your answer for factored form. And if I was going to graph this, there's my axes. Standard form tells us that the y-intercept is -12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm just going to rough estimate here. And the x-intercepts are 3 and -4. 1, 2, 3, and -1, 2, 3, 4. And then that's what the parabola would look like. And I missed it a little bit. That's okay. All right, looks like we're given standard form again. We're asked to find the vertex form. So we're going to do that by completing the square. If we've got 1 flat and we've got 6 red longs, I would put 3 on each side. And if I did that, it would need 9 units in order to complete that square, but we've only got 3. So once I've done that, completing the square, I've got a perfect square of x minus 3, because you're putting half of your longs on each side. That's x minus 3 times x minus 3. We need 9 units, but we've only got 3, which means we're missing the 6 units. So it's x minus 3 squared minus 6. There's your answer for vertex form. And that is a very easy way of graphing, because vertex form tells you the vertex. So it's going to be right 3, 1, 2, 3, down 6, 1, 2, 3, 4, 5, 6. The a term is 1, so that means the next numbers are 1 above. And it's got a normal shape. So it's got the same shape as its parent function of x squared. Question number 3. Now we're given a graph. We're asked to write it in vertex form. All you need to know is the vertex and how far each point is next to the vertex. How far either up or down it is, which it looks like it's about a half. So I'm just going to have to assume that's a half times x minus 2. And it's x minus 2 because the vertex has been shifted or translated 2 to the right and also 3 down. So it's x minus 2 squared minus 3. If I was going to change that in the standard form, I would then need to solve this. Well, x minus 2 squared would be x squared minus 4x plus 2. And then I have to multiply everything by a half and subtract 3. So half of that would be 1/2 x squared minus 2x plus 1. And then subtract 3 from that, and we've got our answer. 1/2 x squared minus 2x minus 2. All right, so there's your standard form. Write factored form for the following equations. Well, first of all, It's a little hard to tell, but it looks like 12, 1, 2. So each block is worth 1, so 11. It looks like from the vertex. Don't know exactly what the vertex is, so that's why I would not want to put it into vertex form. But we do know factored form. So what we do know is we do know where it hits the x-axis. It hits at -5, so one of the factors has to be x plus 5. And the other factor has to be x minus 2, because 2 was the other x-intercept. Now, what I'm having difficulty doing is trying to figure out that a term. It's negative something. I'm going to have to do a little bit of guessing here, because the vertex is a little hard to figure out. So from here to the very next term, I'm just going to assume that it's 1. So I'm just going to leave it the way it is, because it does look a little bit like it's 1. So it looks like it's going down 1. If it's not 1, it's pretty darn close to it. Change that to standard form. Okay, so I need to FOIL this, and that would give me x squared plus 5x minus 2x minus 10. But then you got to multiply everything by -1, the negative on the outside, and you got to combine the two like terms in the middle. So that's going to give you negative x squared minus, let's see, that gives you 3x. Opposite of that would be negative 3x and plus 10. All right. Question number 5. Moving right along. We're given standard form. We want to translate it to something else. Well, I'm thinking the easiest thing to translate to would be vertex form, especially if we have to find the vertex of the parabola next. Because, I'm going to factor out that negative first. So I see the x squared is negative, so I'm going to factor that out first. So we got x squared plus 6x minus 16. All right, so this is a perfect square. Okay, that's going to it's going to mess things up, because now it's not going to be able to make a perfect square. Because if I put, I'm going to do it either way. So -1 times, if I take half my longs, put them on each side, that would be x plus 3 square. And if I make an x plus 3 square, that would mean I need 9 units. But I'm missing 16 to begin with. So if I need 9 more, and I'm already missing 16, that means I'm now missing 25 total. So there's your answer. So it's -1 times x plus 3 squared minus 25. I missed the squared right there. Where's the vertex? It looks like the vertex is at -3, -25. All right, next one. Where's the vertex and what are the x and y intercepts? Okay, so it looks like we're going to need to know both vertex form and standard form. And factored form, sorry. So I'm going to factor it. So 2 times 13 makes 26. We need to know the factors of 26. It's either 1 times 26 or 2 times 13. Or, let's see, 3, there's 4. 4 times, no. 5, no. 6, no. 7, no. 8. I think that's it. Is it negative? No, it's positive, 26. So which of these combinations is going to add up to 26? I feel like I'm missing something. 3 going to 26, 3 times, no. 7, 3 times 8, 24, no. That's not it. 4 going to 26, 4 times 8, 7, 28, no. 5, no. 6, no. 7, no. Okay, looks like this one's not factorable, because no numbers are going to give you 26, but also add up to 12. So what I would need to do is I need a graphing calculator, which I do not have on me. So what I would do is I would put this in the graphing calculator, and I would look at the table and try to find the x-intercepts. Actually, you're going to have to go through quite a tough process, because this is going to be a non-integral answer, meaning the 2 x-intercepts are going to be decimal answers. And the vertex of that, it probably is also going to be a decimal as well. It's not going to show up on the table unless you change your table to go by 0.1s or something else. All right, so I'm going to have to just skip this question because I don't have a graphing calculator on me. And I'm going to look to the next one, and hopefully that's not going to happen again. Well, first of all, I noticed this time, because I looked this time, but I didn't say it, because I always look for a GCF first. 2, 12, and 13 can't all be divided by 2. But these can all be divided by 2. Matter of fact, I'm going to factor out that -2. That negative as well. Yeah, I know. X squared minus 7x, and this would becomes -30. Okay, so what 2 numbers give us 30 but also add up to -7? So factors of 30. We've got 1 times 30, that's not going to help us. 2 times 15, not going to give us 7. 3 times 10, that looks to be the answer. So it looks like it's going to be -10 and +3. So it's negative 2 times x plus 3 times x minus 10. All right, so what are the x-intercepts? The intercepts have to be negative 3 and positive 10. The y-intercept would have to be 60. Okay, the vertex, so if I want to put this in the vertex form, negative 3.5, so that's going to be difficult. It's going to be a decimal again, because if I take half of my longs here, it's going to be negative 2 times an x minus 3.5 square. And I don't know what 3.5 times itself is. 3.5 times 3.5. Let's see if I can do that quickly. 17, 0, 15, 9, 10. I think that was a 10. So 5, 7, 1, 1. So it looks like 11.75, if I'm doing that correctly. And how many units did I actually have? I had negative 30. Okay, so it's going to be negative 41.75 if I did that correctly, and I did it without a calculator, so I probably made a mistake. So it's looking like the vertex is going to be 3.5 and negative 41.75. So pretty crazy. Once again, use a calculator. Grab a calculator. I don't have one. Put the equation in and just look at the table or solve for it. Press stat, calculate, and solve for whatever you want. It'll solve for the x-intercepts. It'll solve for the for any answers. For the vertex, it'll solve for everything that you could possibly ever want. All right, homework. Standard form, vertex form, they gave us factored form. So the easiest thing to do is to change that to standard form. That's going to be x squared, 5x minus 3x makes 2x. I'm just foiling it. 5 times negative 3 is negative 15. All right, if I want to put that in the vertex form, so I take my two longs and I put 1 on each side. So I've got an x plus 1 square, half the longs on each side, half the longs on each side. And 1 long on each side means it needs 1 unit in order to complete the square, but I've got negative 15. So if I've already missing 15 and plus the 1 I need more to complete the square, it means I'm minus 16 is the vertex form. All right, so what I could do is I could make a table here, and I just put 0, 1, 2, 3, 4, and just simply put each one in there and solve to see what it would look like. But you know what? I'm going to graph it using the key features of factored form like we did in the last video. So we know negative 1, 2, 3, 4, 5 is one of the factors. It's one of the x-intercepts, sorry. And 3, 1, 2, 3 is the other factor. We can look at standard form and tell that negative 15 is the y-intercept. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm just going to have to guess at it. And we also know the vertex is at negative 1, negative 16, which would be way down here as well. So the graph is going to look something like that. Okay, I probably should have made the x-intercept be way higher because I ended up with not enough room on the bottom. Show the first differences and the second differences. So 0 is negative, oh, I can just tell it's right there in standard form, 0, negative 15. We know negative 1 is negative 16, so this has also got to be negative 16. That's a difference of minus 1. 2, if I put 2 in for x and solve, 2 plus 5 is 7. 2 minus 3 is negative 1. So it looks like 7 times negative 1 is negative 7. 3 plus 5 is 8. 3 minus 3 is 0. So this is going to be 0. 4 plus 5 is 9. 4 minus 3 is 1. So this is going to be 9. So it looks like this one's going to be... What just happened here? So that can't be right. So let me put them all in here. 0. So that's 5 times negative 3 is negative 15. Yes. 1 plus 5 is 6. 1 minus 3 is negative 2. Okay, so there's the mistake. There we go. All right, so this had to be negative 12. I'm not sure why I got something else. Okay, so now we fixed the problem. So this looks like plus 3 plus 5 plus 7 plus 9. So clearly we can see the second difference is it has a second difference of plus 2. Alright, so there we go. We showed those differences. I'm not quite sure why I had 16 here a second ago. Oh, it's because of the vertex form. So I'm guessing that this vertex form, oh, it's negative 1. Ah, that makes more sense. Negative 1, negative 16. Ah, got it. Got it. So that means negative 2 would have been negative 15.